Hey everyone, thanks for joining us. We are just about to get started here. Today is a really, really big day for us. We just launched the Arbitrum Nitro DevNet and full code base. This is full featured, fully built out Arbitrum Nitro stack, which is going to enable us to have really, really, really high throughput and also lower fees, and definitely the most advanced roll-up stack to date. And we're super excited to put it out there for everyone to use and to check out, and also announce our plans to deploy it on mainnet and migrate Arbitrum One to Nitro. Really, really cool thing is that it's going to be a seamless migration. So what that means is if you have an app that's running on Arbitrum One today, or you're a user that uses Arbitrum One, all of your state, everything's going to stay where it is. Everything's going to be accessible. If you blink, you might not even notice when we make the change. Well, you might have to blink for an hour or two or three because there'll probably be a little bit of downtime. But maybe if you take a little nap, you probably won't even notice that we made a change. But the thing is that you'll notice that the fees will be lower, that the throughput will be higher, and this is a really, really big step for us ultimately to scale way past where we are today. Scaling is basically it's a constant battle because Web3 is taking off and it's accelerating the pace of adoption. And scaling today is not necessarily what scaling will mean in a year or two or three. And I think today, by launching Arbitrum Nitro, we're showing that we have a very, very long vision. Arbitrum 1 is working just perfectly today, and we're already seeing fees that are 95% lower than Ethereum, but we're not stopping there. We're getting ready to scale even further and getting ready for the next billion users. So with that intro, super excited to have the team here hanging out, and I thought it'd be cool if we talk about what is Arbitrum Nitro. Pop the hood a little bit, look under, and we have none other than the engineers who built it, or a bunch of them, on here today. And we have my co-founder Harry Kolodner and Ed Felton, and also some of our engineers. So I think maybe Harry, do you want to start off and tell us a little bit about what is Nitro, what went into it, what was the work that went into it, and how hard of a problem it was that we've solved and shipped today.
Yeah, totally. I mean, I think the first thing to know about Arbitrum Nitro is that it's really damn cool. And also, I slept like 2 hours last night, so this is gonna be fun.
A lot of there. I think you're so.
Arbitrum Nitro is like we we did when we first launched Arbitrum, and we'd been working on Arbitrum for a long time, a lot of years. I mean, from when Ed originally came up with the idea in late 2014, I think it was. And we put a lot of work in, but the thing about development, and the thing about how research goes is there's always room to improve, and there's always kind of lessons learned. And the thing we got to do with Nitro was take all of the learning and everything we kind of had figured out from all of that time, and use all that knowledge to build something even better, which has been like the most exciting experience ever. And kind of being able to do that simultaneously with having kind of our mainnet live has just been so cool. Um, the actual, and we'll get into the details of kind of what changes we've made in Nitro that kind of that give us sort of a lot of new superpowers that we're very excited about. But at its core, we are sort of taking a lot of the kind of a lot of what we had to a lot of the custom work that we had to do in launching Arbitrum initially, because kind of we were breaking new ground, and we were doing things that I mean, basically hadn't been done, and we had to invent a lot, and we ended up with a lot of code and a lot of complexity in order to achieve what we did. But code and complexity are not really things that as an engineer you love to have around. And so the beautiful thing with Nitro is we've been able to have, I'm pretty sure, less code, and more performance by taking the core of kind of what makes Ethereum, which is the EVM, and just directly compiling it into WASM, and running the chain with that, and get sort of higher levels compatibility, higher levels of performance, all the while having a simpler code base and a more accessible code base, which I'd say is, pretty exciting.
Absolutely. And maybe like digging into some of those details, do you want to maybe tell Harry, like, what does it mean to compile Geth to WASM, and what were some of the complexities?
Yeah. So, and it's a good question. So, and basically, I think, in order to, I think Nitro makes the most sense, kind of makes the most sense, sort of in the context of sort of Arbitrum mainnet as it exists today. Um, the way Arbitrum works today is we have the Arbitrum virtual machine, which powers the entire system. And the Arbitrum virtual machine runs a program called ArbOS, which provides basically the entire experience of using Arbitrum. And with Nitro, we've replaced that component with a new component, um, very similar in responsibilities, but a new implementation. And what that means is basically where before we had the Arbitrum virtual machine, now we have the WebAssembly virtual machine, which is a kind of standard execution environment used all over the web and really gaining support very quickly. And one of the cool things, there are a lot of cool things about WebAssembly, but one of the cool things is that modern programming languages can compile directly to it. And that includes Go, which is the language that Geth is written in. And so, where before we had the AVM and we had ArbOS that was actually written in a language that we developed because we invented the AVM and then we needed a programming language for it, so we invented this language called Mini. Whereas with Nitro, we instead are able to take traditional Go code and compile it and run it in a virtual machine. So basically, we have that core facility that we built out. We call it Arbitrator. And then on top of that, basically, you now have the ability to run arbitrary Go programs. So what do you run? Well, of course, you run Geth because we want to be a blockchain. Now, you don't run Geth itself because you want to be an L2 chain and you have a lot of responsibilities and a lot of nuances that you care about that are different than L1 Ethereum. But you take the core of it, you take the execution environment, and you use that. And what that means is that gas will be the same. That's one of the things I'm most excited about. That generally sort of Arbitrum 1 is mostly EVM compatible. It's EVM compatible for almost everybody who uses it. Nitro will push that even further. And it does it by basically saying that your transactions, the core of your transaction is going to run through the same exact code as it would run through if it were running on Ethereum. The gas will be the same. And that's kind of a really huge change. But the other part of this, and the part of Nitro, and I'm sure we're going to dig into this more, that's really interesting to me and really exciting to me, and this gets down into the weeds, is with Arbitrum today, we have the AVM, and when you're running an Arbitrum node, you run your code local. You have an Arbitrum virtual machine implementation locally. Your code runs through that. You get the result. When you are running a Nitro node, you're running Go code bare metal. You're not running a WASM virtual machine locally. You're just running native Go code, which means the performance of the system is just as fast as any other EVM implementation. We've completely eliminated all of the extra virtual machine overhead that the current version of Arbitrum has, which means that the performance of the network is going to go way up. And I think that's one of the areas where there's some real magic in how we accomplish that I'm sure we'll dig into.
Absolutely, yes. That's all super exciting, and yeah, just the ability to run outside of the virtual machine emulation is going to be really, really important for allowing us to really scale up and increase our capacity to, probably 10x plus more than we are today, and maybe even more past that. Ed, turning to you, do you want to tell us more about the compression in Nitro and what we're doing there to reduce the layer one footprint of Arbitrum transactions?
Sure. Yeah. So, in all rollups, one of the biggest sources of cost is transaction data, which needs to get posted on L1. And we did some things in the first version of Arbitrum to try to shrink that. some custom compression, which got some gain, but not a huge amount. So in Nitro, we have fully integrated Brotli compression. And basically the way this works is that the Arbitrum sequencer takes users' transactions and puts them into big batches. And then it does Brotli compression on each batch to make that batch a lot smaller. So why do we do it that way? Well, basically we looked at different kinds of, first of all, Brotli is a state-of-the-art compression algorithm that was developed initially by Google, which is open source. And we, as Harry said, one of the big benefits of Nitro is that we can run code, we can compile in any code written in Go. And so we had our choice of any state-of-the-art compression algorithm that that's been developed by anybody. And we looked at a bunch of different algorithms. We looked at Brotli, we looked at zlib, we looked at some of the other ones that were out there, and did a little study and concluded that Brotli was the best. It got the best compression on general data sets and also on Ethereum transactions. And so every transaction that you submit through the Arbitrum sequencer is getting Brotli compressed, and that saves a big factor. It saves around a factor of 2 in the size of the of your transactions, and that is one of the things that drives lower cost in and will drive lower fees once we transition mainnet over to Arbitrum 1 mainnet over to use Nitro. But I want to say one more thing about this because this is really important. What we have done in building Nitro is not just one component. We didn't just build a bunch of separate components. One of the really important things here we did is we built an integrated system that includes all of these components. Right? One of the big lessons we've learned in rolling out a complete roll-up system already is that it's a lot of work, requires a lot of engineering effort, a lot of innovation to figure out how to make the pieces fit together. And so we have compression, and we have compression in a way that's integrated with a complete system in Nitro. So we're really excited about that. We not only have what we think is the best compression system that exists for Ethereum transaction data, we also have the ability to switch to anything new that comes along that's better. So just another example of how the flexibility of being able to write Nitro in a high-level language pays off for us in the ability to make pretty much anything better if we discover how.
Absolutely. And one other thing I want to flag on the flexibility of the stack is today is obviously really important because Arbitrum Nitro is going to be on Arbitrum 1. We're going to migrate Arbitrum 1 to the Nitro stack. But it's also a big day for Arbitrum AnyTrust chains, which we announced a few weeks back. And these are the gaming specific chains that are ultra low cost and still high security, but make a slightly different trade-off. And the cool thing is all the work we're doing internally is built on the Nitro stack. So the Nitro stack, as Ed mentioned, is incredibly flexible. And one other way that it's incredibly flexible is that will allow us to build other scaling technologies on top of it. And one of those are the Nitro stack. We have also here, first of all, actually, I want to shout out, so not the entire team is here today, but one person I want to particularly shout out is Lee, who is the Nitro tech lead, who started off, basically, Nitro started off as a side project that he was working on and really became a full company priority. And we wouldn't be here without Lee. We wouldn't be here without the entire team, but Lee deserves definitely a very, very special shout out. And he's not here today. And also Rachel, who's not on today, deserves a very special shout out. And Safi, who is here today, as well. And we also, speaking here, have Daniel Goldman. So Daniel, do you want to tell us, I guess, more about, are there any changes coming to the smart contracts or the bridges? Is that going to be seamless? Anything users should look out for in Nitro Stack, or cool nuggets that really speak out to you on the smart contract side?
Oh, sorry, but just before you go into that, just one thing I love, which is just so cool and is basic Nitro went from being a weekend project to being okay, this is what we're all working on in a week. that was how quickly it went from a germ of an idea to okay, let's all work on this for the next many months.
Absolutely.
Yeah.
And just, there is, we've been looking at WASM for well over a year now, how to get WASM. But then, we had different approaches. Some of them were, slightly different than Nitro, but really once Nitro came together, yeah, as Harry said, it started moving very, very, very quickly. And the speed to launch today is really, really, as an insider, I'll still say it, really impressive, and took a really incredible effort on behalf of the entire team. But anyway, Daniel, yes, we have the one and only Daniel Goldman. So
yeah, just first of all, yeah, second the shout out to Lee, who, I call him our secret weapon. He's done such amazing work on this. He's I'm trying to find at Plasma Power Zero, I think, on Twitter. Yeah, hopefully we can get him on one of these spaces soon. Yeah, I mean, I think in terms of Nitro from sort of the application or smart contract level, what's exciting is sort of like Harry was saying, what's currently live on Arbitrum 1 is like very, very, very Ethereum and EVM compatible. And I think one of the, in terms of like things we've learned from being live, one of the things that we've seen that's maybe kind of surprised me is like those slight divergences are big pain points for developers. Probably the big one being sort of the way gas accounting works, how just the gas accounting of certain operations, from the perspective of a Solidity developer on Arbitrum isn't exactly what you expect if you're just taking your knowledge of Ethereum. And that's just by virtue of the fact that Arbitrum currently has its own custom virtual machine. So, we support all the Ethereum operations. They work basically the same way, but the exact gas accounting is different. And again, that seems like, a small detail people can work around, but that pain point is real for developers. So yeah, the fact that with Nitro basically just goes away. We can sort of go from saying, we can say now we're like very, very Ethereum compatible, and you almost certainly won't have to do extra work for to have support on Arbitrum. We can say now you like really, really, really almost certainly don't have to do extra work. It's like very close. You can, almost certainly take your contracts, deploy them on Arbitrum, and they'll work the same way you expect them to. So that's like the big example, but there's a number of other ways that this will just sort of make life easier for developers, which I think will be very nice. Devs can do something, which is exciting. And then, yeah, I mean, obviously for users, you'll see lower fees. That's kind of the big thing. But yeah, some of the most interesting and maybe the most counterintuitive aspects to Nitro have to do with some of the performance gains that Harry alluded to, which maybe gets a bit too wonky, but we can go into that later.
I mean, I feel like if there's a day when like we deserve to be able to be wonky, it's today. Like this is our day, Daniel. Come on, we can be wonky.
Well, let me to close the loop on Steven's question. In terms of like the application level stuff that we have, like our token bridge and things like that, yeah, I mean, one of the, a sort of nice demonstration of the fact that, the Nitro transition is and can be smooth is that like we don't really have to update any of those contracts. Those work on Arbitrum 1 and they'll work on Nitro 2. And they work currently on the Nitro testnet. So yeah, so that's all exciting. And yeah, I mean, if we want to get into it, I can grill you a bit on this performance thing. But I guess, well, yeah, unless anyone has anything else, I'll just keep talking. Harry.
No, I'm so game. I mean, my favorite thing about like, about Arbitrum and about like optimistic rollups is that like you can actually explain them. Like you can actually like go into the details. Like there's nowhere where I'm like, okay, there's a black box here, just assume it works. Like we can go like and we can talk about in any amount of detail and like it just clicks together. There are a lot of different pieces, but they all come together in this beautiful way.
Yes. So let's talk a bit about sort of what execution looks like on Arbitrum 1 versus what it looks like on Nitro. And you sort of alluded to this, how basically, on Arbitrum 1, we have to sort of, code gets compiled down into AVM code, it gets run that way. Whereas on Nitro, we can run Go code directly. Can you maybe even start to talk about, it's a bigger question, but why that is and what's the root of that difference?
Yeah, no, and there's like one very precise kind of technical detail, and this definitely is on the wonky side of things. Where but I'm game. Like we're basically with the way that, so in both cases, like the fundamental ideas of the system are no different. You have this idea of kind of a machine that's running, and you can use bisection to dispute the results. Like that's Arbitrum 1, that's Arbitrum Nitro, no difference. But there's one really big difference between them that changes a lot of things. Where in Arbitrum 1, we just have a single long-running program that's kind of the entire lifetime of the chain. It runs forever. It's sort of just, it's the thing. The program says, okay, take the next transaction, process it, output a receipt. And it does that over and over and over again. Whereas with Nitro, instead, there's a program which says, okay, here's the previous block, here's the transactions, I'm going to output a block, and then I'm done. I'm not going to keep running, I'm just going to do this one thing. And the cool thing that comes to that is basically we just checkpoint between blocks. We don't checkpoint in the middle of a block. And so basically, if you have two programs that are equivalent, if I can kind of in some quick way find out what the end result of a block is, rather than needing to run the whole slow WASM version, I can use my other approach, my shortcut approach, which is, in this case, just running it natively. It's the same program. I'm just running it in two different ways. The result's going to be the same. And I can just run it quickly. And I can continuously know what the result of the WASM program would be without actually running it. And this is compared to with Arbitrum 1 today, where the AVM program, the only way to know what the result is to run it. There's no kind of notion of sort of intermediate checkpoints or anything that's kind of equivalent that lets you bypass it. And that's one of the kind of most interesting kind of performance improvements that we get from Nitro.
Yeah. So in other words, I mean, on a very high level, a lot of the benefit of things like optimistic rollup is sort of taking advantage of this happy case and then having this sort of fallback case that rarely, if ever, needs to happen. But the happy case is better. And this is sort of kind of another example of that in some sense, right? So in the unhappy case where we need to prove fraud, which again, that should rarely happen, maybe even never, but if it does happen, it'll be a very rare event. Then you have to do this sort of heavy performance intensive compilation. In this case, compiling your code down to WASM so you can bisect, blah, blah, blah.
But only ever on a single block. You never need to do more than just one single block's worth of work, which is pretty cool.
Even in the unhappy case.
Even in the unhappy case, because essentially, so with Arbitrum 1, we basically just have this bisection, which is over the program. And essentially with Nitro, we have sort of two levels. We have the block level, and then we have inside a block. And at the block level, we just bisect on blocks until we get to a single one, and that's like very lightweight because there you don't really care about the WASM side of things.
Right.
You only get into the WASM when you get to that kind of, I need to know whether or not this single block was done correctly.
Right. So Arbitrum 1, we like bisect between assertions, which are these things that happen once in a while. Whereas with Nitro, the bisection part down to the operation starts between blocks. So even in the unhappy case, but more importantly, the unhappy case should be rare or never happen. In the happy case, we're just sort of running essentially Geth or a fork of Geth, which is much more performant and kind of a big deal.
And it's interesting. It kind of gets you. I mean, it there's a lot of. I mean, there's a lot of like, what's the next thing? But one of the really interesting questions is sort of like, how do we do even better? Which is, I think, something that like we're going to be wrestling with over the next, we'll see if it, maybe we'll have next one, a solution in 4 months if we did this in 6. But it's how do you get even more performance than like an EVM chain can get, and really continue to kind of scale up and be able to handle more traffic, and a whole different set of problems to solve.
Yeah, and we've had some of these discussions where there's a bit of a push and pull, I think, where on the one hand where there's these new avenues of research that we can explore, on the other hand we don't we want to sort of stay in line with what Ethereum is doing to stay Ethereum compatible. But yeah, I mean, we'll see. I think L2 is sort of a fun place to experiment, or at least think about some of these alternative ways to, for example, improve performance. So yeah, fun stuff. What would you say, Harry or Ed, who wants to chime in terms of like what were the biggest challenges in terms of getting to Nitro? Either like conceptual research questions or even just implementations, surprises that came in, or was it all just smooth sailing for everyone?
It's a good question. Ed, do you wanna?
Yeah, I guess It went fairly smoothly. Obviously, there's a ton of work to figure out how to make all the pieces fit together. I guess I'd point to a couple things. One was how to one was around how to interface with Geth, sort of how the interaction between the core of Geth, which is providing the EVM compatible functionality in Nitro, how that interacts with the with the rest of the layer 2 software. So that is things like, right, because you need to do some things in order to be a layer 2 system. You're not just Ethereum. You know, you need to, there's bookkeeping you need to do to make sure that the sequencer gets paid, and there are issues around how things like time are handled to make sure that you provide the right experience for applications and developers. So figuring out how Geth and the rest of the L2 system, which we loosely call ArboS, should work in order to not have to modify Geth, but to still be able to have the pieces work together cleanly. I think that's one piece. There's another piece around how to do the seamless transition of a running Arbitrum chain onto Nitro, and make sure that all of the state gets migrated over in a clean way, so that the user experience is of a seamless upgrade. That was one of the interesting pieces. I think those were the main ones, but really there were no conceptual showstoppers that I can think of.
The other thing I would throw in there is like proving over WASM.
Yeah, I guess, right. Figuring out how to prove over WASM, that's a very cool piece of it. And there are a bunch of clever tricks in the way that we do that, right? So
yeah, like generally speaking, like it's not even, we're actually, the whole WASM thing, we're almost running WASM. We're actually running a like thing that is very, very WASM like, which is like an easy one-to-one transformation from WASM, because there are certain instructions that we figured out, like, well, we can't actually prove this, but you can decompose it into this other set of instructions that can be nicely proven.
Right, or that there are instructions that are in WASM, but we don't need to have the compiler generate them in order to be able to run smoothly. And then the final piece of this is the hash oracle trick, where in order to figure out how you can read the Geth's database. Geth has a database where it keeps the Ethereum state tree or state trie, and figuring out how you can efficiently prove things about what's in the database. And that basically involved taking a trick that we were already doing in our existing Arbitrum stack, which is for allowing programs to navigate hashed trees of data. And just recognizing that we already had a method of having a hash tree of data and navigating that hash tree and having very simple proofs of that, and that we could adapt that method to allow us to access the Ethereum state tree. I think that was one of the key tricks that we brought in relatively early, how to do that and how to do that in a way that's provable. But all the pieces sort of, once we got our heads wrapped around the system, and once Lee had done this sort of initial caffeine-fueled weekend of demonstrating feasibility of this, once we said, okay, let's get a team and let's figure out how we can turn this thing into a complete system. I think the rest of it built out in a pretty nice way.
Yeah, just to add, actually, specifically chocolate covered espresso beans.
Okay, yeah, good.
It's an important fact.
Yeah.
Those are caffeinated in 2 ways. Huh? Yeah.
That's how you get Nitro. Nitro is powered by chocolate covered espresso beans.
Yeah, it's covered by chocolate covered espresso beans, really smart and dedicated people, plus all of the experience that we've built about how to build and operate a complete rollup system. I think those are the three main ingredients.
Yeah, I mean, some of the work that's gone into the, sort of from my end on the application side, but I think generally also some of the work that's already been done is less fundamental things necessary for Nitro, but more like, since we're doing this update, let's also, improve things where we can and use things we've learned. So there's just a number of other nice like optimizations and improvements kind of around the edges that will be, that will make life nicer and easier. Things like, we've just rethought certain message types, cross-chain messages, things around that. Rachel had a nice optimization of a new way of doing the outbox that just kind of makes a lot more sense. That's probably like, oh yeah, we should have done this the first time. There's a number of changes like that too.
And like tracing, tracing has been, and we actually finally have now shipped just yesterday we finally shipped a version of Arbitrum 1 that supports tracing, which was something we spent a lot of effort working on because we're kind of doing this. We did it from the ground up. Whereas with Nitro, we will just have tracing out of the box. There's certainly kind of specific work, and kind of Rachel's done some really cool work on kind of the Arbitrum specific parts of the system. So the parts that like are not sort of standard EVM around kind of precompiles and stuff like that, and getting tracing to work nicely for those. So there's been a lot of cool stuff there, but fundamentally, like regular EVM execution, we just had geth tracing out of the box and fully complete, which is pretty damn useful.
Yeah, I meant to bring up tracing as well, but that's a very good example of just like geth node, things that are implemented in the geth node, they're not necessarily part of consensus, but are like widely used, and block explorers expect them and things like that. That's really useful too. And then instead of the node engineering team having to like think about re-implementing all of these things, we just sort of inherit it from geth. So that's huge.
So then we get almost everything we need from geth. And as Harry said, there's this little extra piece, which is there's a bunch of bookkeeping and other stuff that the ArboS component has to do for every block. Rachel did this very clever bit of engineering to surface all of that stuff as a transaction. If you go into the block explorer, you'll see these start block transactions, which are labeled as transactions from ArboS to ArboS. And that's basically a way of taking the little bit of work that that you need to do in order to be an L2 system for each block. And by wrapping that into a transaction, what you get is something that is traceable. And so all of that stuff shows up in the block explorer, and it all shows up through the tracing interface. So everything that happens in Nitro is traceable because of that. So there's a bunch of smaller innovations, which when you have a team that is as fantastic as our team, you have people inventing cool things and just like building them into the system every day. And that's a great example of an innovation which is going to really pay off for users and developers over time. That that is built into Nitro. So Nitro is a moonshot, but at the same time, it has like a whole bunch of really awesome roof shots built into it. Really nice bits of engineering that contribute to the overall effect.
Yeah, yay, Lee and Rachel. That's the real theme today.
That's a big theme. Yeah, they're not here, so they would be talking, or would deserve to be talking a lot if they could be here.
We'll do this again with them in a couple of days.
And for anybody who wants some real technical alpha, there's a lot of cool stuff in the Nitro repo in the way of kind of internal documentation that we've been working on, kind of talking about the details of kind of how all the tech works. So for anybody who's not too scared off by some markdown files on GitHub, there's some very cool stuff there.
And feedback is welcome, because we're trying to figure out how best to communicate this stuff as well as build it. So yeah.
Awesome. Well, I think maybe you could take just a few questions from people in the crowd. If you want to speak, just raise your hand. Questions about Nitro, though, please.
Steven, what's your favorite food?
My favorite food is, I think we just said, coffee beans covered in chocolate.
Wait, you weren't supposed to answer though because it wasn't about Nitro. I got you.
Okay. Well, my favorite.
But you made it about Nitro, so it counted.
Oh, good. Hunter, do you want to bring someone up if there's anyone?
Can do.
All right, what's your favorite food?
Hey, can you hear me? Hey, thanks. This has been awesome. So, quick question: if there was a multi-round interactive proof on WASM, how'd that get interpreted on the EVM on mainnet?
Yeah, absolutely. So basically, there's kind of two phases to the fraud proof protocol. At the kind of top level, at the rollup, you're making assertions about blocks, and you're just basically kind of the assertion contains the hash of a block header. There's then two phases. So the first phase is bisecting down to a single block, and then the second phase is bisecting the WASM program, which is the state transition, which takes the previous block and produces the next one. And as kind of the base of that, basically kind of at the mid through that, you're just sort of there is sort of a way of describing the virtual machine it's running on by its hash. The whole thing is kind of shaped as a tree, basically. And once you get to the one-step proof part, to the single instruction, then we have a full implementation. It's not quite the WebAssembly virtual machine. It's a very slightly modified version, just because certain opcodes are a bit painful to prove, and it was a lot easier to kind of break them down into sub opcodes. But that is all implemented in Solidity. So just like Arbitrum today, we're kind of fully virtualizing, we're fully kind of emulating the execution at the on-chain level, except just now with a different virtual machine.
Yeah. And just to be clear, all this stuff exists and works in the testnet, in the devnet that's there, right? So you can go into the repo, you can see in the repo the Solidity contracts that can check one-step proof claims about any WASM instruction that might actually occur in the code.
Yeah, and there's a lot, like if there's a lot of tests we have that run through different permutations of this. I know because whenever we commit PRs to the repo, it takes a long time to run them all, because we have a lot of extensive use of it. Since you want to be obviously very, very careful in implementing this kind of thing.
Yeah, and just to sort of reiterate, it's sort of if you're familiar with how Arbitrum works now, and just going back to the question in terms of the fraud proof, like the bisection system, it's a very similar principle. There's a few differences, but probably maybe the big important difference is that there's like these two phases of bisection now. So you bisect blocks, and then once you bisect down to a block, you sort of open that up and bisect essentially this this trace of steps. Whereas in Arbitrum 1 currently, it's essentially you're bisecting this essentially execution trace or something like it. But yeah, that division gives you the nice performance boost that we talked about earlier. Yeah.
And by the way, one of the, just to highlight, it's kind of funny because the question was about the fraud proofs, and we're talking about the code and the tests we have written. It's this really ironic thing, which is there's all these tests and code, and a lot of code, you can look at it written around these fraud proofs, but really in practice we don't expect fraud proofs to happen, right? We don't. The incentives are such that you really wouldn't want to prove fraud, claim fraud, and no one would really want to make a fraudulent claim. So it's one of those really cool things about mechanisms where you need the fraud proof mechanism to be there. A lot of complexity there, and it really dictates how the system is built and how the system works. But these are code paths that will, in all likelihood, not run, really ever in production. So kind of a really, really fascinating thing. But you need to make sure they can run. You need to make sure they don't have bugs, because that's what secures the system.
Yeah. So just to emphasize this, when we do testing, we spend most of the testing time end to end on testing this fraud proof mechanism. But in production, it should never get used.
I think when I first met you guys, when you said, we built this fraud proof system so we could run it in demos, which I thought was a funny way to put it. But yes.
Cool. Thank you, Louis, for that question. Hunter, anyone else?
Yeah, I'd love to chime in. Kind of just obligatory. A few on this call are from the Blocks research team, and we just have a great respect for you guys. Apologies about my voice as well. But I know Ed touched on the hash oracle trick, and for maybe in layman's terms, or to reiterate it, how will that help potentially with the performance of Nitro, or just even relate to it?
Yeah. So let me talk a bit about this. So one of the cool things about Nitro, and Harry talked about this earlier, is that when a Nitro node is doing normal execution, it's doing normal Geth things. And so in normal execution, the node it's keeping the same data structures that Geth is keeping because it's the Geth code, and it uses the same database that Geth uses. So in normal execution, you're just doing Geth things, just using the database in a native way. It's only if there is a dispute and somebody has to prove what happens within one block. And when they do that, when they're proving within a block, then they might need to prove every time that the Geth code would read the database. There's going to be this bisection process, which is going to narrow down the dispute between two parties to a single operation. And if that operation is reading the database, then what Geth does is inside the guts of Geth, it's taking a particular hash which identifies a sort of node in the database's tree, and it is putting in that hash, and it's reading from the database what is a block of data which would hash to that particular hash value. So that's what you do in normal execution, and that's what Geth is doing all the time. But if you need to prove in the dispute process that what the result of reading the database would be, because reading the database takes as input a hash value and produces as a result a block of data which is a preimage of that hash. The way that you prove that is just by producing the data. And then the proof checker can just check, yeah, that data does hash to the value that was passed into Geth. So that's kind of the hash oracle trick, basically, because Geth organizes its database sort of as essentially as blocks of data that are indexed by hash. It's easy to prove what the result of reading from a particular hash would be by just producing the data. But the beauty of this is that only happens when you're proving. In normal execution, you're just running exactly the Geth code, which just accesses the database saying, give me the block with this hash. It's as fast as Geth.
Thank you, Ed.
Thanks.
Thank you, Abraham, for your question. Hello, Socknug.
Hello. Very thankful that you guys let me come up here and talk really quick. Huge fans of Arbitrum since day one. I've been excited for Nitro, so I had to jump in as soon as I saw the space. I just kind of got a question if I can ask, if that's all right.
Yeah, of course, please.
So I'm just kind of interested on what how the fair sequencing services and Chainlink is going to layer in on top of Arbitrum Nitro, because that's just, you're going to get speed like Solana and security of ETH with decentralized consensus as well. So like that's kind of like the main package. So I just want to hear you guys kind of talk about why that's important to you and Arbitrum.
Yep, I'll take this one. Yeah, so fair sequencing is something that is in the future, still on the roadmap, right? So Nitro is a big upgrade for Arbitrum. Our future roadmap still contains all of the steps needed to fully decentralize the system. And so that means decentralizing validation. You'll be hearing more about that one from us. But a bit important part of that is decentralizing the sequencer. So the sequencer in Arbitrum has two big advantages. It's fast. That is, it gives users a response time of usually under a second. And it's fair, meaning that it's first come, first served sequencing of transactions, right? And so obviously, we want to decentralize that. And that means going to a fair sequencing implementation that that relies on a committee of sequencers that can collectively ensure fairness and fast response time, assuming that the committee is fair. And so we'll be moving to distributed fair sequencing over time, and we'll be saying more about the roadmap for doing that.
That's really exciting. I can't wait to hear more and start playing on the Nitro DevNet. Are there any platforms that you know that are going to be spinning up DevNet like apps for Nitro like right away that you guys recommend so I can play around?
We don't plan on really launching our own apps, but we have a lot of people that will building with us. So we do expect that there will be apps to play with on Nitro. And if you're a developer, feel free to launch your own. It's open and permissionless. But we will definitely tweet out when people do build cool things on Nitro.
Awesome. Thank you. I just want to make sure I'm staying tuned so I can start playing around with it right away. Thank you, Ed, for taking my question. Can't wait for SmartCon.
Thank you.
Thank you.
John Adler.
Hi, John.
Can you guys hear me?
Yes.
Okay. I have two questions. The first one is, could you guys describe in as wonky details as you would like to describe, as Daniel and Harry would say earlier, why and how specifically Arbitrum Nitro would be more performant than Arbitrum 1?
So, absolutely. So fundamentally, we're doing less layers of virtualization with Arbitrum, and I think I should say Arbitrum 1 essentially will be running with Arbitrum Nitro. I don't even know what the terminology is here, but like I'm comparing Arbitrum 1 today essentially versus our current Nitro DevNet. So basically today there's multiple levels of virtualization. We have sort of you write code in the EVM. We then have the EVM code compiled down to AVM, which was fundamentally designed kind of to be easily proven on Ethereum. It was not designed to be fast. It as someone who spent a fair amount of effort trying to optimize its execution, there's a lot about it that is really annoyingly slow. Compared to the EVM, which is obviously not exactly the fastest virtual machine ever. And so that's kind of the multiple layers of sort of virtualization there is a big factor. That in combination with the fact that sort of there's no, so that's really in a way the biggest thing, because it's the EVM is also a virtual machine. When you run an Ethereum node, when you run any EVM node, it's not like you're running smart contracts natively. So it's not as though we can say we're getting rid of that virtualization completely. The big innovation is basically the way smart contracts run normally. You fundamentally don't have any concise way of breaking down the state into small enough components to be able to efficiently prove it. And so you need something there. You can't just you need some way of sort of checkpointing at a finer grain than sort of the full transaction level if you want to be able to prove kind of arbitrarily complex execution. And so you need something. And the trick is having as little layers as possible to get there. And basically sort of the combination of just getting rid of the AVM and eliminating that layer, and this sort of intermediate checkpointing that we described, which is kind of the part that I find the most interesting. Basically, the fact that you don't need to run the same program that is running on chain locally. You can run a program that has that you can guarantee has the exact same output as the program that you will prove over, and that's good enough. And so you sort of open your way to any possible sort of optimization. So like just-in-time compilation of any sort, anything you can do to speed things up locally, as long as kind of you're keeping determinism is viable, compared to kind of on the AVM approach where you couldn't optimize because everything had to be identical because we were gas metering on the exact execution of the machine, and there were just really hard limits in kind of how well you could optimize that.
Yeah.
One other thing that I'd add on this is there's also just like an engineering piece here, which is it was an incredible feat of engineering actually that we built the Arbitrum, the current Arbitrum node from the ground up, and got as performance was, but obviously Geth has a lot more, years more of open source development on it. So there's the fundamentals that Harry was speaking to, which, based on your question for the wonkiness is probably what you wanted, but there's also just the optimization points, which Geth just has years more of optimization. And the fact that we had the Arbitrum 1 node from the ground up, didn't require that was itself a feat of engineering, but ultimately, when the question became, should we continue to optimize this stack or should we go on this approach, which has fundamental advantages, but also allows us to make use of all the, the optimizations that were already built into Geth? It was a clear choice to go to the second, and it's just a clear win from that perspective as well.
Yeah, and then I would just add quickly that there are some other parts of the system that we built where we were able to take advantage of what we learned from having done it once before. And so, some of those components, you could find a 10% win here, a 20% win there, and those things also compound up. So all those pieces together really are what led to the performance advantage.
Just to call out, just because again I'm trying to be wonky. Two things that were really annoying, two great optimizations that were really annoying to implement in the current Arbitrum 1 system. One is memory locality. Just the way the AVM is designed, it's really hard to have decent memory locality because we have kind of these tuple structures and nested values where it's like fully typed. There's a lot going on in the virtual machine. And it's also really hard to do like state prefetching. You really don't have any idea what you're going to do until you do it. And so it's really, really hard to like do any of the sort of like nice, fancier optimizations you would want to do that like have been figured out pretty well in the context of kind of the EVM.
That's very informative. Thank you so much. It actually explains a lot. For my second question, one token.
And that is why I said, please stay on Nitro. So, but thank you. Someone had to do it, and I appreciate you for that.
Input.
Awesome. Let's bring up another. We'll do two more speakers. So here we have one, Albie. Oh, we have two joining.
While we're waiting, I just want to say to John, I don't know if you know this, but you can permissionly bridge any token from layer 1 into Arbitrum. So we actually already support every token on Ethereum. So yeah, hope that answers your question.
So yeah, great answer. Maybe it looks like Albie is still connecting. So Angelfish.
Hello. I think that with Nitro, something that's really cool was how super powerful it is to have this technology of like a WASM fraud prover. And I'm curious if you guys have thought about ways to leverage this in the future. Like this could be a natural path towards new VMs or just ways that you could maybe like use this WASM prover in the future for Arbitrum.
Yeah, I think you're touching on something really important, which is the stack is modular, and the WASM prover itself is important. And the fact that we compiled Geth to it was a decision we made, but sort of a separate piece. And I think what you're getting at is, hey, can we take this and compile some other stack or other VM to this? So The answer is it's definitely something which we've thought about, which is how can we leverage this to really experiment. And when Ed was mentioning before, the flexibility, that this is a big part of it. The fact that we can be so flexible, we have a prover, it means we can move things to native code, even in the current stack, and just like do custom precompiles. We can also definitely think about other VMs. Right now, that's definitely not what we're working on. We're working on giving the best EVM experience. But when we think long term about the next billion users that come and the next many million developers that come, they won't all be EVM developers necessarily. And there is a question of can we continue to have best in class EVM support, but also think about ways to incorporate other tool chains either on top of the same stack or in parallel. And it's not something which is a focus at all now. We're fully focused on the best EVM experience, but it's something which is in the back of our minds, and it's something which we'll definitely get back to think basically how can we create a more inclusive environment here and offer the best EVM experience together with something else, and the flexibility of the WAS improver, the fact that it's not tightly coupled to the EVM, I think is a very, very big part of that. So a really good observation you make, which is definitely something we've thought a lot about. Yes.
I think also I just want to add that I just thought about how I think Celo recently decided that they were going to switch to becoming a rollup. And a lot of these L1s are actually going to start switching to becoming rollups on Ethereum, maybe. And I'm curious if like they could leverage this WAS improver that you guys have built in like potential options. I don't know.
So yeah, from a technical perspective, if their code can compile to WASM, then they have there's obviously a lot more to it and to actually building the full system, but that's a big piece. If their code can compile to WASM, then that's a really good start to roll-upifying, if I can coin that term, their protocol. So another great point. And if anyone is interested in that, anyone out there, please get in touch with us. Definitely. Again, not our focus right now, but it's something which is definitely possible. I'm told Hunter messaged me the word is rollify, not roll-upify, so I apologize to all of you for saying roll-upify.
I think, yeah, I just wanted, now I'm laughing too much. No, I just wanted to add that, yeah, the idea, like the flexibility in execution environments is one of those like really cool long-term things. Like I'm really looking forward to like, the amount of sort of just, experimentation that's made possible. Like, not experimentation on Arbitrum 1, not experimentation like where like money is at stake, of course, because that's something you have to take extremely seriously. But the ability to sort of in testnet environments, for example, how many EIPs are there out there that are like really cool ideas that have like never gained adoption and never had like the amount of effort put in to like launch a testnet, which is like a relatively long, complicated process, that you could, for example, have kind of quickly spin up a roll up that kind of has that. I mean, how many EIPs are sitting around like implemented, somewhere in the back end of Geth, but not actually activated, that like people would love the opportunity to play around with.
Yeah, and I'll also just add to just my previous point before, which is, I'm approaching that question from a technical perspective, from a community perspective. Like I said, our full focus is on Ethereum. We believe that the future of smart contracts is on Ethereum, and that's why we're excited to build that. But like from a technical perspective, for the question was, from the perspective of how many people can we bring to Ethereum with this tech, I think it's really, really, a very important foundational technology that will ultimately grow the Ethereum ecosystem significantly. Awesome. There was Albi. I don't know if they connected or they left. It seems like.
Yeah, I think they left.
Okay, so I think this might be a good time for us to wrap. Thanks everyone for coming and listening today ad hoc. We'll do more of these, like I said. Lee from our team and Rachel, really pivotal in building the Nitro stack, aren't here today, but I think we'll definitely want to do another Twitter Spaces with them, and you can go even more into the weeds on a few things. Take a look at the code and ask us questions, play around with it, check out the DevNet. There's a Twitter faucet with you maybe might want to warn your friends before you use the Twitter faucet, because it's a bit of the message is a bit much. Thank you, Hunter, for drafting that. Yeah, thanks everyone for coming. Check out Nitro. We're super excited. We have a clear path to mainnet migration now, which is our full focus, and you'll also be hearing more from us around any trust chains, decentralizing the sequencer, and a lot more that we have, in the works. I guess the last thing that I'd say is, if any of this sounded interesting to you today, and if you're a developer, front end, back end, you name it, if you are a sort of business development person, if you have really any skill that you think could be useful for us, please apply. We have our career site. It's offchainlabs.com/careers. And there's also one option there which says, hey, if you don't see the right job, just apply here. So we need all the help we can get. Our team is still small but mighty. And if you think you have something to offer, we want to talk to you. So please apply to join our team. And again, thanks everyone for joining today. We'll do this again soon. But in the meantime, check out Nitro and let us know what you think. Bye, everyone.
And if you join last minute, we'll be putting it up on YouTube. So no worries.
Bye.
Adios, guys.